Okay, here we have polyethylene terephthalate or PET, which is widely used as one of the basic ingredients for synthetic fibers such as the crowns, mylar, and Coke bottles. And here is the structure of the PET. Now the question A, the PET is made from the monomers of ethylene glycol, which is ethane 1.2-diol, or benzene, and benzene 1,4-decarboxylic acid. So then we here want to like draw the structure. So basically here, from the structure of the PET, the polyethylene terephthalate, we have to find the functional group in which it comes from the condensation reaction. So in this case, this would be this one. This is the ester group. Okay. Now the ester group is resulted from the reaction of carboxylic acid and alcohol. So basically, we have something like this, COOH. So this is to be double like this. And then it reacts with another molecule which also have like OH and then OH. So that we will end up with a monomer, something like this, in which these will be forming the ester group, something like this. So basically, we want to like break that down. So from the structure, then we can divide this into like two parts. So the first one here, so this is the breaking down, the ester. So the first one should be the carboxylic acid and the other one should be the alcohol. So in that case, the monomer here should be this one, and this is the benzene group, and this is the COOH. Now this one here is the decarboxylic acid. So this is basically the benzene 1,4-decarboxylic acid. And the other one comes from this side. This is the alcohol side. So then we can then draw, this one should be the alcohol, so CH2, CH2OH. And this is basically the ethylene glycol. So this is the diol, or I'm going to write here, this is the ethane 1,2-diol. And then the question B, the ethylene glycol can be oxidized to aldehyde compounds. So we have alcohol, primary alcohol, and then it can be oxidized to aldehyde. And then it's this aldehyde compound that can be further oxidized to produce carboxylic acid. And then we want to like draw the structure. So basically, we start from this. This is the alcohol, primary alcohol. And then this is oxidized. So the first one we have is the aldehyde. So in this case, we will have aldehyde. So it's basically this one here. Okay. And then the next oxidation should result in carboxylic acid. So in that case, we have this. Okay, so we have primary alcohol and then oxidized to result in aldehyde. And then the result of the aldehyde is oxidized further to result in carboxylic acid. Okay, now the question C, when the ethylene glycol is reacted with butane 1,4-dioic acid, a polymer can be formed, and we draw the structure of the polymer. Okay, so we have ethylene glycol, and then we have the butane 1,4-dioic acid. Okay, so here we have butane 1,4-dioic acid. So we have basically 4C here, and then 1,4, that is the position of the carboxylic acid. This is number 1, this is number 4. And then it reacts with the ethylene glycol. Okay, so the result should be a polymer in which it comes from the condensation reaction. So basically we are going to like react this, the COOH, that is the carboxylic acid, and the alcohol over here resulting in ester. So in that case, the structure should be okay. So this is forming ester with the alcohol. So this one here, and then you have like the ethylene glycol. This is the OH. Okay, so here we have to put M, and this one should be this. So this is the polymer that is that was resulted from the reaction. So in this case, this is also having the COO, which is the ester group here, coming from the carboxylic acid and the reaction with alcohol. The next one here, ethylene glycol can be synthesized from 1,2-dibromoethane reacted with hydroxide ions while releasing bromide ions. Write down the reaction that occurs. So here we have 1,2-dibromoethane. So basically we have ethane, 2 carbon, 1, 2. And then at the number 1 and 2 we have like bromo side group here. So 1,2-dibromoethane. Then we complete the hydrogen number over here. And then we react it with hydroxide ion, so OH minus, while releasing the bromide ion. Okay, here. So basically we want to like substitute the bromide with OH minus. So here we have like 2. So this is the result. So we have alcohol as the result. This is OH, this is OH, and 2 bromide ions. So here we have alcohol. So this is basically a diol of the ethan 1,2-diol as the product.